Hi, I am Danica Kate C. Ganaganag, a BS Math student. So now, I will be discussing about Unit 4.1, which is Probability Distribution. So now, I will be discussing on how to distinguish discrete random variables and continuous random variables, constructing and graphing a discrete probability distribution, verifying and identifying a probability distribution, and how to find mean, variance, standard deviation, expected value of a discrete probability distribution. So now, let's start.
So now, I will discuss and tackle about on how to distinguish between discrete random variable and continuous random variable. But before we're going to tackle about these two random variables, first I will give you the definition of random variable. So random variable, it represents a numerical value associated with each outcome of a probability distribution, and it is denoted by x. So there are two types of random variable. First is discrete random variable. Second is continuous random variable. So first, discrete random variable. It has a finite or countable number of possible outcomes that can be listed. So for example, let X represent the number of Fortune 500 companies that lost money in previous year. So solution, the number of companies that lost money in the previous year can be counted. So therefore, it is a discrete random variable. So second is continuous random variable. So it has an uncountable number of possible outcomes represented by an interval on the number line. So for example, let X represent the volume of gasoline in 21-gallon tank. So solution, the amount of gasoline tank can be any volume between 0 gallons and 21 gallons. So therefore, it is a continuous random variable. So next is how to construct and graph a discrete probability distribution. But first, I will give you the definition of a discrete probability distribution. So a discrete distribution describes the probability of occurrence of each value of a discrete random variable. A discrete random variable is a random variable that has countable values such as a list of non-negative integers. So there are two conditions so that you can identify and verify that the probability is a discrete probability distribution. So first is the probability of each value of the discrete random variable is between 0 and 1 inclusive. And number two, the sum of all the probabilities is 1. So there are methods also for you to construct a discrete probability distribution. So constructing a discrete probability distribution. So let X be a discrete random variable with possible outcomes. So X sub 1, X sub 2, and so on. So first method is make a frequency distribution for the possible outcomes. Second, find the sum of the frequencies. Third, find the probability of each possible outcome by dividing its frequency by the sum of the frequencies. Fourth is check that each probability is between 0 and 1 inclusive. and that the sum of all probabilities is 1. So for example, an industrial psychologist administered a personality inventory test for passive-aggressive traits to 150 employees. Everyone was given a whole number score from 1 to 5, where 1 is extremely passive and 5 is extremely aggressive. A score of 3 indicated neither trait. The results are shown. Construct a probability distribution for the random variable x. Then graph the distribution using a histogram. So we are going to use the methods to construct a discrete probability distribution. So first method is make a frequency distribution for the possible outcomes. So as you can see in the table, the frequency of 1 is 24, the frequency of 2 is 33, the frequency of 3 is 42, the frequency of 4 is 30, and the frequency of 5 is 21. So the second method is find the sum of the frequencies. So as you can see in the table, the frequencies are 24, 33, 42, 30, and 21. So the frequency is 150. So the third method is find the probability of each possible outcome by dividing its frequency by the sum of the frequencies. So as you can see, the frequency is 150. So P sub 1 is equal to 0.16. P sub 2 is equal to 0.22. P sub 3 is equal to 0.28. P sub 4 is equal to 0.20, and P sub 5 is equal to 0.14. So this is the table of the discrete probability distribution. And the last method is check that each probability is between 0 and 1 inclusive, and that the sum of all the probabilities is 1. So as you can see in the table, the probabilities are 0.16, 0.22, 0.28, 0.20, 0.14. So the sum of the probabilities is equal to 1. So this is a valid discrete probability distribution since each probability is between 0 and 1 inclusive, and the sum of the probabilities is equal to 1. So therefore, this is a discrete probability distribution. So the third part is how to verify and identify a probability distribution. So, as what I have tackled earlier about the conditions to identify and verify that the probability is discrete probability distribution. So, these are the two conditions. Number 1 is the probability of each value of the discrete random variable is between 0 and 1 inclusive. Number 2, the sum of all the probabilities is 1. So, verifying a probability distribution. So for example, verify that the distribution for the 3-day forecast and the number of days of rain is probability distribution. So as you can see in the table, the probability of 0 is 0.216. The probability of 1 is 0.432. The probability of 2 is equal to 0.288, and the probability of 3 is equal to 0.064. So, solution. Each probability is between 0 and 1. So, as you can see in the table, the probabilities are between 0 and 1. And in number 2, all the probabilities, the summation of the probabilities is equal to 1. Both conditions are met. Therefore, the distribution is a probability distribution. Identifying probability distributions. So example, determine whether each distribution is a probability distribution. So as you can see in the table, the probability of 5 is 0.28. The probability of 6 is 0.21. The probability of 7 is 0.43. And the probability of 8 is 0.15. So solution. Each probability is between 0 and 1, but the sum of all the probabilities is equal to 1.07, which is greater than 1. The sum of all the probabilities in a probability distribution always equal to 1. So this distribution is not a probability distribution. So the last part is how to find mean, variance, standard deviation, and expected value of a discrete probability distribution. First is mean. So mean of a discrete probability distribution. So the formula is mean is equal to the summation of x times p of x. So each value of x is multiplied by its corresponding probability and the products are added. Example, the probability distribution for the personality inventory test for the passive-aggressive trait is given. So find the mean score. So as you can see in the table, the first column is multiplied by the second column, which is the third column. So the probabilities are 0.16, 0.44, 0.84, 0.80, 0.70. So the mean is equal to 2.94, that is congruent to 2.9. So recall that a score of 3 represents an individual who exhibits neither passive nor aggressive traits, and the mean is slightly less than 3. So the mean personality trait is neither extremely passive nor extremely aggressive, but is slightly closer to passive. Variance and standard deviation. Variance of a discrete probability distribution. So the formula is variance is equal to the summation of x minus mean squared times p of x. Standard deviation of a discrete probability distribution. So standard deviation is equal to variance. The square root of variance is equal to the square root of the summation of x minus mean squared times p of x. So, for example, the probability distribution for the personality inventory test for passive-aggressive traits is given. Find the variance and standard deviation. So as you can see in the table, the probabilities are 0.16, 0.22, 0.28, 0.20, and 0.14. Recall that mean is equal to 2.94. So as you can see in the table, this third column is x minus mean, right? So x, this column, x, was differentiated from the total mean, which is 2.94. So these are the answers. So negative 1.94, negative 0.94, 0.06, 1.06, and 2.06. So these answers was squared in order to get these answers in the fourth column. So x minus mean squared. So the answers are 3.764, 0.884, 0.004, 1.124, and 4.244. So in the last column, in order to get these answers, you have to multiply this column to the second column, the fourth column to the second column. So the answers are 0.602, 0.194, 0.01, 0.225, and 0.594. So, in order to get the variance, you have to get the summation of this column, or the total probabilities of this column. So the variance is 1.6164. And in order to get the standard deviation, you have to get the square root of the variance. So the standard deviation is equal to 1.3. So most of the data values differ from the mean by no more than 1.3. So the last topic is expected value. Expected value of a discrete random variable equal to the mean of the random variable. So the formula is E of x is equal to mean is equal to the summation of x times p of x. So for example, at a raffle, 1,500 tickets are sold at $2, each for prizes of $500, $250, $150, and $75. You buy one ticket, find the expected value, and interpret its meaning. Solution. To find the gain for each prize, subtract the price of the ticket from the price. So first, your gain for the $500 prize is $500 price minus $2 is equal to $498. Second, your gain for the $250 prize is $250 minus $2 is equal to $248. Third, your gain for the $150 prize is $150 minus $2 is equal to $148. Fourth is your gain for the $75 prize is $75 minus $2 is $73. So if you do not win a prize, your gain is $0 minus $2 is equal to negative $2. Probability distribution for possible gains or outcomes. So as you can see in the table, the probability of $498, $248, $148, and $73 is 1 over 1,500, and the probability of negative $2 is 1,496 over 1,500. So solution. So in order to get the expected value, you need to multiply the gain x, and the probability of it. So this one, you have to multiply this one. And after that, you have to add all of the answers of these probability. So $498 times 1 over 1,500 plus $248 times 1 over 1,500 plus $148 times 1 over 1,500 plus $73 times 1 over 1,500 plus negative $2 times 1,496 over 1,500 is equal to $1.35. Negative $1.35. So, you can expect to lose an average of $1.35 for each ticket you buy. Okay, so that's all. Thank you for listening and goodbye.